Top 25 MEP Engineering Interview Questions and Answers. In this video, we will explore the top 25 interview questions and answers specifically tailored for MEP engineering professionals. This comprehensive guide aims to prepare candidates for success in their upcoming job interviews in this dynamic field. From technical inquiries to behavioral scenarios, we'll cover a range of topics that are commonly encountered during MEP engineering interviews. Equip yourself with the knowledge and confidence needed to excel and stand out to potential employers. 1. What is MEP engineering, and why did you choose this field? MEP Engineering, which stands for Mechanical, Electrical, and Plumbing Engineering, encompasses the design and implementation of essential building systems that ensure functionality and comfort. I chose this field due to my passion for integrating technology with sustainable practices. The ability to create efficient systems that enhance occupant comfort while minimizing energy consumption excites me. Additionally, MEP engineering plays a critical role in shaping modern buildings, providing a unique opportunity to contribute positively to the environment and society through innovative solutions. 2. What are your short-term and long-term career goals? In the short term, I aim to gain practical experience in MEP engineering by working on diverse projects that challenge my skills and expand my knowledge in HVAC, plumbing, and electrical systems. I want to pursue relevant certifications to enhance my technical proficiency. Long-term, my goal is to become a licensed professional engineer, leading innovative projects that prioritize sustainability and efficiency. I envision myself in a managerial role, mentoring junior engineers, and contributing to the development of best practices in the industry, ultimately impacting the future of building design. 3. How would you describe yourself, and how do others perceive you as an engineer? I consider myself an adaptable and proactive engineer, always striving for innovative solutions. My colleagues often describe me as detail-oriented and collaborative, which helps foster a positive team environment. I value communication and actively seek feedback, ensuring that I remain approachable and open to new ideas. My technical skills are complemented by my ability to understand client needs, making me effective in translating complex concepts into manageable tasks. This balance allows me to excel in both individual and team projects, contributing positively to project outcomes. 4. Can you explain the components of HVAC systems in building design? HVAC systems consist of several key components that work together to provide heating, ventilation, and air conditioning. The main components include the heating unit, typically a furnace or heat pump, the cooling unit, such as an air conditioner or chiller, ductwork for air distribution, and ventilation systems to ensure proper air exchange. Additionally, thermostats control temperature settings, while filters clean the air. Each component plays a vital role in maintaining indoor air quality, comfort, and energy efficiency, contributing significantly to the building's overall performance. 5. What steps would you take to design a plumbing system for a new office building? When designing a plumbing system for a new office building, I would start by assessing the building's layout and occupancy. This includes determining the number of fixtures, their locations, and expected water usage. I would then select appropriate piping materials and sizes based on flow rates and pressure requirements. Next, I would create a schematic design that outlines the hot and cold water supply, waste, and vent piping systems. Coordination with other MEP systems is essential to avoid conflicts. Finally, I would ensure compliance with local codes and regulations, followed by a thorough review and revisions before finalizing the design. 6. How do you calculate electrical load for residential and commercial projects? Calculating electrical load involves several steps. First, identify the types of electrical devices and their ratings, including lighting, heating, cooling, and appliances. Next, determine the wattage for each device and sum the total wattages. For residential projects, apply the National Electrical Code (NEC) guidelines, considering factors like demand factors for lighting and receptacles. In commercial projects, include additional considerations like diversity factors based on expected usage. Finally, ensure that the calculated load does not exceed the panel capacity while allowing for future expansions or additional electrical needs. 7. Can you clarify the distinction between grounding and earthing? Grounding refers to connecting electrical systems to a ground reference point, typically the earth, to prevent electrical shock and ensure safe operation. It provides a pathway for fault currents, helping to protect equipment and personnel. Earthing, on the other hand, is a broader term that often describes the process of connecting electrical installations to the physical ground. While grounding primarily focuses on electrical safety, earthing can also encompass grounding practices. Understanding these distinctions is crucial in designing safe electrical systems and ensuring compliance with relevant standards. 8. What factors do you consider to design energy-efficient buildings? When designing energy-efficient buildings, several key factors must be considered. First, orientation and layout play a crucial role in maximizing natural light and minimizing heat gain. Selecting high-performance insulation and energy-efficient windows enhances thermal performance. Implementing renewable energy sources, such as solar panels, can significantly reduce dependency on non-renewable energy. Efficient HVAC systems and smart building technologies contribute to reduced energy consumption. Finally, water conservation measures, like low-flow fixtures and rainwater harvesting, complement energy efficiency efforts, creating a holistic approach to sustainable design. 9. Which types of pipes are commonly used on construction sites, and what are their permissible standby pressures? In construction, several types of pipes are commonly used, including PVC, CPVC, PEX, copper, and steel. PVC pipes are widely utilized for drainage and irrigation due to their lightweight and corrosion resistance. CPVC is often used for hot water applications. PEX is flexible, making it suitable for residential plumbing. Copper pipes are favored for their durability and reliability in water supply. Steel pipes, particularly black iron, are used for gas lines. Each type has its permissible standby pressure, which varies based on material and application. For example, PVC can handle pressures up to 280 psi for certain sizes. 10. Tell me about a challenging MEP engineering project you managed. How did you overcome obstacles? One challenging MEP engineering project involved retrofitting an aging commercial building with modern HVAC systems while ensuring minimal disruption to tenants. Faced with outdated infrastructure and limited space, I conducted thorough assessments to identify viable solutions. Collaboration with contractors and stakeholders was crucial for innovative designs that met efficiency standards. Through regular communication and flexibility in adjusting the project timeline, we managed to complete the retrofit successfully, significantly improving energy performance while minimizing tenant inconvenience. 11. What was your most successful engineering project to date and what made it successful? One of my most successful engineering projects was the design and implementation of a state-of-the-art HVAC system for a large commercial complex. The project was successful due to thorough planning and collaboration with architects and other engineers. By conducting extensive load calculations and utilizing energy-efficient technologies, we achieved optimal comfort levels while minimizing energy consumption. Effective communication with the client ensured their needs were met, and regular quality checks maintained high standards throughout the project. The positive feedback from both the client and end users highlighted the project's success. 12. How do you handle project failures or setbacks? Handling project failures or setbacks requires a methodical approach. First, I analyze the root cause of the issue to understand what went wrong. Engaging with my team allows for diverse perspectives, which often leads to innovative solutions. I prioritize transparent communication with stakeholders, ensuring they are informed about the challenges and our strategies for resolution. Implementing corrective actions is essential, and I take notes on lessons learned to optimize future projects. This proactive stance fosters a culture of continuous improvement and resilience within the team. 13. How do plumbers fit into the MEP engineering process? Plumbers play a crucial role in the MEP engineering process by ensuring the effective design, installation, and maintenance of plumbing systems within buildings. They collaborate with MEP engineers to integrate plumbing layouts with HVAC and electrical systems, ensuring optimal functionality. Their expertise is vital in selecting appropriate materials, adhering to building codes, and implementing water conservation measures. Plumbers also conduct pressure tests and troubleshoot issues, contributing to the overall efficiency and safety of the building's infrastructure. Their hands-on skills complement the theoretical aspects of MEP design, creating a cohesive system. 14. Describe your approach to coordinating with other engineers and disciplines on MEP projects. Effective coordination with other engineers and disciplines is crucial in MEP projects. I prioritize open lines of communication, ensuring regular meetings to discuss project goals and address any potential conflicts early on. Utilizing collaborative tools and software, I share drawings and updates in real time, allowing for immediate feedback from structural, architectural, and civil teams. I also emphasize understanding each discipline's requirements, fostering respect and collaboration. By maintaining detailed documentation and scheduling joint reviews, I help ensure all parties are aligned, which minimizes errors and enhances project efficiency. 15. How do you troubleshoot electrical system problems in a building you've designed? To troubleshoot electrical system problems, I first conduct a thorough inspection of the system, checking for visible signs of wear or damage. I utilize testing equipment like multimeters and circuit testers to measure voltage, current, and resistance at various points in the circuit. By cross-referencing these measurements against my design specifications, I can identify discrepancies. Additionally, I review the system's layout and wiring diagrams for potential design flaws or code violations. Collaboration with other engineers or electricians is essential for resolving more complex issues efficiently. 16. What process do you follow for testing completed projects and quality control checks? To ensure project quality, I begin with a comprehensive checklist that outlines all testing requirements specific to each MEP system. This includes functional testing, performance verification, and safety inspections. I collaborate with project teams to schedule tests systematically, prioritizing critical systems first. During testing, I meticulously document results and address any discrepancies immediately. Post-testing, I evaluate the data to confirm compliance with specifications. I also conduct a final review with stakeholders to ensure satisfaction and gather feedback for future projects. 17. How do you ensure safety compliance in your design plans? Ensuring safety compliance in design plans involves a thorough understanding of relevant codes and standards, such as OSHA and local building regulations. I conduct a comprehensive risk assessment during the initial design phase, identifying potential hazards associated with MEP systems. Regular collaboration with safety officers and project stakeholders ensures all safety measures are integrated. I also implement design reviews and site inspections to verify compliance during construction. Training and communication with the installation team are crucial, enabling them to follow safety protocols effectively. 18. Explain your approach to sizing ducts and pipes in HVAC and plumbing systems. In sizing ducts and pipes, I start by assessing the specific requirements of the system, including airflow needs, pressure drops, and fluid dynamics. For HVAC, I calculate the necessary airflow using the building's heating and cooling load demands, applying methods like the equal friction method or the velocity method. In plumbing, I consider the flow rates needed based on fixture units and any applicable codes. After determining the required sizes, I verify them against established standards, ensuring compliance while optimizing for efficiency and performance. This approach balances functionality and cost-effectiveness. 19. Describe how you would design a drainage system for a multi-story commercial building. Designing a drainage system for a multi-story commercial building involves several key steps. First, I would perform a thorough assessment of the building's layout and usage patterns to determine water flow and potential drainage points. Next, I would calculate the expected drainage loads, considering factors like roof area and occupancy. I would select appropriate materials and sizes for pipes to ensure efficient water flow and prevent clogs. Importantly, I would incorporate a combination of gravity drainage and pump systems where necessary, ensuring compliance with local building codes and regulations for effective drainage management. 20. Describe a situation where you resolved a conflict between different MEP systems in a building project. In a recent commercial project, we faced a significant clash between the HVAC and plumbing systems due to space constraints. The HVAC ducts were initially designed to run through the same area designated for plumbing lines, creating a potential conflict. To resolve this, I organized a collaborative meeting with the HVAC and plumbing teams to review the designs and assess the physical layout. By utilizing 3D modeling software, we identified alternative routes for the ducts and pipes. This not only alleviated the conflict but also enhanced the efficiency of both systems without compromising functionality or performance. 21. What codes and standards are you familiar with for MEP design, for example, ASHRAE, NEC, NFPA, IPC? I am familiar with several important codes and standards relevant to MEP design. ASHRAE Standards Guide HVAC System Design, ensuring energy efficiency and indoor air quality. The National Electrical Code, NEC, outlines safe electrical installations, while NFPA standards focus on fire protection and safety systems. Additionally, I adhere to the International Plumbing Code, IPC, which provides guidelines for plumbing systems and fixtures. Staying updated with these codes is crucial for compliance, safety, and producing designs that meet industry regulations. 22. How do you incorporate client feedback in your design and during project delivery? Incorporating client feedback is essential for a successful design process. I begin by actively listening to the client's needs and preferences during initial meetings. Throughout the project, I maintain open lines of communication, using regular updates and review sessions to gather their input. I encourage clients to express their thoughts on design drafts and proposals, ensuring their concerns are addressed promptly. By integrating their feedback into revisions, I create designs that align with their vision while maintaining technical integrity. This collaborative approach fosters trust and strengthens the client relationship, resulting in a more satisfying project outcome. 23. Explain how you use AutoCAD or other software in your design process. In my design process, I utilize AutoCAD extensively for drafting and modeling MEP systems. It allows me to create precise layouts, ensuring all components fit seamlessly within the architectural framework. I leverage its features for layering, annotations, and dimensioning, which enhances collaboration with other disciplines. Additionally, I often use building information modeling, BIM, software like Revit to develop 3D models, which enables better visualization and coordination of MEP systems. This integration helps identify potential conflicts early, streamlining the design process and improving project efficiency. 24. How do you communicate complex engineering problems and solutions to clients or non-engineering stakeholders? Clear communication is essential when engaging with clients or non-engineering stakeholders. I begin by breaking down complex concepts into simpler terms, using analogies or visuals when possible. Active listening helps me understand their concerns, allowing me to tailor my explanations accordingly. I prioritize transparency, sharing the rationale behind decisions while addressing any potential impacts on the project. Regular updates and check-ins ensure that stakeholders feel informed and involved throughout the process, fostering trust and collaboration. 25. What sets you apart from other candidates with similar qualifications and experience? My unique blend of hands-on project experience and strong communication skills differentiates me from other candidates. I have successfully managed diverse MEP projects, demonstrating my ability to tackle challenges while maintaining attention to detail. My commitment to continuous learning allows me to stay updated with industry advancements, ensuring I bring innovative solutions to the table. Additionally, my collaborative approach fosters strong relationships with clients and team members, creating a conducive environment for productive discussions and successful project outcomes. In this video, we explored the top 25 MEP engineering interview questions and answers that can help you prepare for your next job opportunity. Understanding these questions not only boosts your confidence but also equips you with the knowledge needed to impress your interviewers. Remember, preparation is key in landing the job you desire. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more insightful content. Your support helps us create more valuable resources for you.